This is the same problem in non-preemptive SJF. As I said, even though when a lower burst time process arrives while the longest burst time process is executing, it won't get preempted. After completion of this process only, next arriving process will be allocated for its execution. Such a way, if at the time of 0 milliseconds the process P1 arrives, so P1 will get allocated for its execution. The complete burst time of process P1 is 8 milliseconds. Till its completion, it won't get preempted. So from 0 to 8 milliseconds, the processor will be occupied by the process P1. After completion, at the time of 8 milliseconds, the process P2, P3, P4 will be arriving and it will be waiting in the waiting queue. Then comparing all those P2, P3, P4, P2 has the minimum burst time. So then P2 will be allocated. The starting time of P2 is 8 milliseconds plus its burst time 4 equal to 12 is the completion time of process P2. After that, the process P3 and P4 will be compared. In that, the process P3 has burst time of 9 milliseconds and P4 has burst time of 5 milliseconds. In this, P4 has smallest burst time, so P4 will get allocated for its execution. P4 starts its execution at the time of 12 milliseconds and 12 plus its burst time 5 equal to 17 is the completion time of process P4. After that, process P3 will be allocated for its CPU execution. The process P3 starts at 17 milliseconds plus its burst time 9 equal to 26 is the completion time of process P3. Then using this Gantt chart, we will be finding the turnaround time and waiting time. The formula for finding the turnaround time is turnaround time equal to completion time minus arrival time. For process P1, completion time is 8 milliseconds minus arrival time is 0 equal to 8 milliseconds is the turnaround time of process P1. Then for process P2, the completion time is 12 minus arrival time is 1 equal to 11 is the turnaround time of process P2. For process P3, completion time is 26 minus its arrival time 2 equal to 24 milliseconds is its turnaround time. Then for process P4, its completion time is 17 milliseconds minus its arrival time is 3 milliseconds equal to 14 is the turnaround time of process P4. For finding the average, we will be summing all those turnaround time of process P1, P2, P3 and P4. 8 plus 11 plus 24 plus 14 equal to 57 divided by 4 equal to 14.25 is the average turnaround time for all those 4 process execution under non-preemptive SJF. Using this turnaround time, we will be finding the waiting time of all these processes. For finding the waiting time, formula used is waiting time equal to turnaround time minus burst time. Using this, for process P1, its turnaround time is 8 minus its burst time is 8 equal to 0 is the waiting time of process P1. For process P2, turnaround time is 11 minus its burst time is 4 equal to 7 is the waiting time of process P2. For process P3, its turnaround time is 24 minus its burst time 9 equal to 15 is the waiting time of process P3. For process P4, its turnaround time is 14 minus its burst time 5 equal to 9 is the waiting time of process P4. For finding the average waiting time, we will be adding all those waiting time of process P1 to P4 and find the average. So 0 plus 7 plus 15 plus 9 equal to 31 divided by 4 equal to 7.75 is the average waiting time of this process executing under non-preemptive SJF. Since in the last session itself we have seen how to solve the same problem under preemptive SJF. In general, if we solve the same problem under preemptive and non-preemptive SJF, preemptive SJF will be resulting in average minimal waiting time. For the same problem, while solving under preemptive SJF, we had the average waiting time of 6.5 millisecond. Then during now, if we solve the same problem under non-preemptive, we have got average waiting time of 7.75 millisecond. So usually the problems solved under preemptive SJF algorithm is considered as optimal algorithm with average minimal waiting time for CPU scheduling. That's it for today's session. Thank you.